I first saw this puzzle in 2001, and I solved it by hand. Today, I'm going to show you the technique I use to solve it. It's not the simplest way to get a solution, but anyone can do it, and I like it. So, what are the rules of this puzzle? You have a 10 by 10 grid, and you need to make a path through the grid that visits every square cell in the grid exactly once in some order. 1, 2, 3, all the way up to 100. At each step, you can step in any of 8 directions. If you go horizontally or vertically, you need to step exactly 3 squares, and if you go diagonally, you need to step 2 squares. So you start at 1 and go to 2, and I went right by 3 squares. From 2 you go to 3, and I went diagonal by 2 squares. From 3 to 4 I went down by 3 squares, and so on. And the challenge is to visit all 100 squares exactly once each. You should give the puzzle a try and just pick which direction to go randomly. Eventually you'll get stuck, like I did here at 64. Every square I could move to at this point is already taken. You might get farther than that, but you almost certainly won't make it to 100 just by guessing. So, how can you do better than guessing? If you've done Sudoku, you might think that you can make a series of logical deductions that let you fill in the squares one by one. It won't get you anywhere though, because Sudoku has exactly one solution, whereas this puzzle has a huge number of solutions. You can't deduce anything about them because there's very little that they all have in common. So we need another approach. Here's how I'll do it. First, label each square in the grid with one of the 25 letters A through Y so that each label appears in 4 different squares. Next, find a path that passes through a square with each of the 25 labels exactly once. Then, just repeat that path 3 more times for a total of 4. Each letter will be visited 4 times, which means every square will be visited once. Let's get started. We want to give a different label to every square in the top left 5 by 5 quarter of the grid. In the first row, A, B, C, D, E. In the second row, F, G, H, I, J. And so on to Y to fill in the top left quarter. Now we want to have the same labels in each of the other 3 quarters, but with different orientations. For the upper right quarter, instead of having A, B, C, D, E along the top row, we have it down the rightmost column. Then F, G, H, I, J down the column next to that, and so on. For the bottom right quarter, we start going left along the bottom row, and for the bottom left quarter, we start going up the leftmost column. I'll highlight the different quarters of the grid pink and blue like this, just so it's clear which is which. So, why label it this way, with the letters going in different directions? The directions are this way so that when you rotate the grid a quarter turn, all of the squares keep the same label after you rotate. So, the A in the upper left gets rotated to the upper right, which was also an A to begin with. All the A's rotate into other A's. Similarly, B's, C's, and every other letter rotates into another square that had that same label before the rotation. Now, what we want is a path from the A in the upper left to the A in the upper right that visits a square with each letter exactly once. Then we rotate the grid 90 degrees and follow the same path again, but starting at this A and ending at this A. If we repeat it a total of 4 times, we'll hit every square in the grid. Okay, so how do we find a path like that? It doesn't seem any easier than the original problem. Well, we just need to represent the connections between squares in a different way. What squares is A connected to? From A, you can reach D going right, M going diagonal, or P going down. So from A, you can get to D, M, or P. Also, that's the same for every A. From this A, you can also get to D, M, or P. From B, you can get to E, N, or Q. From C, you can get to U, O, R, or K. Also, when you go from C to U, you cross from the pink section to the blue section. Whenever that happens, let's mark it with a dot. And vice versa. If you were to go from a blue C to a U, it would be a pink U. That'll be important later. From D, you can get to P, W, S, L, or A. The ones that take you from pink to blue are D to P and D to W, so those get dots too. When we get to I, we see that we can go from I to Q, X, X, Q, or F. There are 2 different ways to get from I to Q, and 2 different ways to get from I to X. In both cases, one way takes you from pink to blue, and one from pink to pink. So, when we go from I to Q or I to X, we can choose whether we change colors or not. I'll mark connections like this with 2 dots. When we get to S, we see that we can go from S to S. We're going to exclude that possibility because we know that a path that visits every label once will never go from S to S. Also, when we go from S to Y, it's still pink to pink even though it's in a different quarter of the grid. So S to Y does not get a dot. Once we have all the connections listed, we're going to forget about the grid for now. We'll make what's called a graph showing the connections. Each label A through Y will be a node on the graph, and if you can get from one label to another label, there will be an edge connecting those two nodes. Let's start with the labels with the most connections and work our way down to the labels with the fewest connections. The Y node is the only one connected to 8 other nodes, so let's start with Y. Next are the nodes with 7 connections. N has 7 connections, so let's add to the graph, and since N and Y are connected, we'll draw an edge between their nodes. Also, I'll mark nodes that have been added to the graph with dots. The next node with 7 connections is O. It's connected to Y, but not to N. R also has 7 connections. Of the nodes that are already on the graph, it's connected to Y and N, so it should go somewhere it can easily connect to both of those. T has 7 connections and is connected to N and O. W is the last one with 7 connections and it's connected to O and Y. I'll skip ahead to where I've added everything with 8, 7, 6, or 5 connections. Next is everything with 4 and then 3 connections. It's definitely getting crowded, but that's okay. Try to make straight edges and avoid crossing edges when you can, but you can't completely avoid it. The last one is Q, which is connected to B, I, and T. So there is my graph. Yours might look different, but that's fine. We need to find a path through the graph that visits every node exactly once and winds up back where it started. Also, remember there were some connections marked with 2 dots, which means we get to choose whether we change colors or not. I want to make sure to include at least one of those, so I'll choose the connection from I to Q. And now just try it. You don't have to use a lot of logic or strategy, but one thing that helps is to prefer to visit nodes that don't have many connections left when you can. So from Q I'll go to B, because B only has 3 connections. I see I can get the whole bottom section by going from B to E, K, C, U, and N, and then you get out of that section by going to R. And at this point I realize I made a mistake. F is connected to I, R, and U has already been visited, so the only way through F is I to R. But if I do that, I'll close the loop before I visited every node, so I need to backtrack and try again. Start again with I to Q. The mistake I made last time was blocking off F, so I'll start there. From I to F, R, J. But I like what I did last time with clearing out the bottom, so let's go from Q to B, N, K, C, U, X. That covers the whole bottom left section of the graph. From J, G only has 3 connections, so I'll go from J to G, V, S. From X, L now only has 3 connections left because J is already used, so I'll go from X to L. It looks like I can use everything in the middle right here, and the top part is easy. So now we have a solution. I know it seems like guessing, but if you try it, you'll see that guessing actually works pretty well here. Let's copy down this path, starting with A and going to P. So following the path, we see A, P, H, W, Y, and so on, ending at D. There's one more tricky thing we need to do. Go back to our list of connections and count the number of times we use a connection where you change colors. These are the ones that are marked with a dot. We start with A to P, which does not have a dot. P to H does not have a dot. H to W does not have a dot. W to Y does have a dot, so I'll mark that on our path with a dot between W and Y. We also have a dot between T and O and between U and C. Between Q and I we have 2 dots. That's the connection we made sure to include, the one where we can decide whether or not to change colors. And finally a dot between V and S. In total our path has 4 single dots and the double dot. Remember, each single dot means we change colors, and the double dot means we have the option of changing colors. So in total our path has 4 or 5 crossings between pink and blue. We want to hit all 4 A's, which means we want to go from pink to blue to pink to blue. If we went from pink to pink, we'd never reach the blue A's. That means we want our paths to cross between colors an odd number of times. So we want an odd number of color changes, and since our options are 4 or 5, we want 5. So when we go from Q to I, we need to make sure that we do change colors. I'll cross out one of the 2 dots to indicate that we should treat it as a single dot. Now let's fill in the final grid. Go back to the grid with the letter labels and use this sequence to place the first 25 numbers. We start with 1 at A, next is 2 at P. So from this A where we started, the P that we can get to is this P here. H is 3, W is 4, Y is 5. Since we have a dot between W and Y, we're going to change colors from pink to blue. Y to M, so M is 6, E is 7, T is 8, O is 9, and again, since there's a dot here, we change colors when we go from T to O, from blue back to pink. Skipping ahead, Q is 17, and here's the critical choice. We need to make sure to change color when we go from Q to I, so that we have an odd number of color changes total. From the blue Q where we are, we have the option of this eye in the blue section or this eye in the pink section, so we want the one that's a changing color. V to S is our last crossing, so we wind up in the blue section. From S we go to D, and then back to A. And that's really it. This path hits exactly one of each label and winds up at the upper right corner. Now we need to repeat the path, starting with the A in the upper right to P, H, W, and so on, and eventually we'll get to 51 at the A in the lower right corner. Repeat the path again to get to 76 at the A in the lower left corner, and finally start in the lower left A to fill in every remaining square. The ending at 100 will always be one step away from the one back where we started. There you have it. Every square in the grid visited exactly once, which solves the puzzle. I hope you enjoyed this. Good luck.